Alrighty, we are live.
Woohoo. Okay, so yeah.
Okay. Well, I'll go ahead and read what we're going to be working on. A manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. To determine if a new assembly procedure is effective in reducing the time, he measures the amount of time in minutes 9 of his workers takes to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different and use the level of significance of 0.05. So design the study. What is the research question?
Is my new procedure faster?
Okay. And state the null and alternative hypothesis. Uh, well, your null is basically these 9 workers take at 100 products equals X, and then your alternative would be it does not equal whatever it equaled before, right?
Well, because we're taking the difference, the null hypothesis is going to be equal to 0.
Okay,
And
yeah,
then our alternative, I think in this case, our alternative is it's going to be not equal to 0.
yeah,
Okay.
you're right. You're right. It should be 0. Now that you say that, you're right. Let's see. Oh, yeah, and the answer key agrees with you, so
I love it when the answer key and I agree.
that's always good. Okay.
Um, so on mine, I already went and found the difference of the two
Okay.
and did the whole analyze means and show us everything. Because that's what we need for the third one. But for the second one, collect the data. He just wants us to describe how the data was collected,
Yeah.
which would be that the manager collected the data.
Yeah. Collected the assembly time from the 9 factory workers before the change, and then the same 9 after the change. So a lot of that's kind of interesting. It goes back to, I don't know. I thought it was kind of interesting. It goes back to kind of the uh, when we work up experiments in science and stuff, how you only change one variable, so you have to use the same people and everything else.
Mm-hmm.
Um, okay. So on. Okay. So we just go to transform, compute data, and do pre-assembly change minus post-assembly change.
I did it the other way around, post-assembly subtracted from pre-assembly.
Oh. Post-assembly subtracts pre-assembly?
That's what I did. And that it might be pre-assembly. I just put in kind of what they had shown in the tutorials online. You want to do the post first and then the pre.
Okay.
Because that'll either show you if your, like for instance, in this case, if your post-assembly time is 10 and your pre-assembly time is 11, that shows that you took 1 minute off the assembly time.
Okay. Okay. And then are you arithmetic? Trying to figure out because it's not letting me hit OK yet.
Did you type in what the target name is?
Oh. Okay.
I think it's up on the top left. You have to enter what the name of that column's going to be.
Okay. There we go.
Did that work?
Okay, what did I just do? Okay, I think I did something weird there.
What happened?
Oh, there we go. Okay, so did you get for the first person, it took them, I guess, 90.9 less. The second person, 2.4 more. 0.8 less, 2.3 less, 1.9 more. Sounds right?
Yep.
Okay. So
for this next one, in describing the data, I didn't do a paragraph. I just said that our sample mean is what I figured out from the difference. So all I did here is I just went on SPSS to analyze, and then the descriptive statistics, the explore function. That's all I did.
This and this.
Oh, I guess we're supposed to do a graph too.
Okay. So the difference mean is negative 1.0556.
That's what I got.
Okay.
And then a standard deviation of 2.596.
Yeah. That's what
And
I
then
got.
our sample size was 9.
Yeah.
Okay.
Okay. That makes sense. Okay.
How do I get this? Like that.
Let me see. So what type of hypothesis test is appropriate?
I'm
Two-tailed,
thinking,
right? Because you're saying that it's not 0, right? So you're not saying
right.
it's more than, you're not saying it's less than, so it'd be two-tailed? Or am I
hmm
on the right path there?
I think so, and I think because of that, we would want to do matched pairs, or what did I call it? Matched, a paired t-test, however you want to call it.
Okay. Okay. So then we're going to do a t-test on that.
Yes, sir.
And what do we do? A paired samples t-test, right?
I don't think it matters if we do a paired sample t-test from the pre and the post, or if we do just a one sample t-test from the difference. It'll give us the same answer.
Yeah. Wouldn't it be better if I use water? Too? Do like a dump broth?
That was the one thing that blew my mind. I actually watched the supplementary videos today.
Okay, and so basically we can use either a two sample using the both or a one sample using the difference?
Mm-hmm.
Is that what? Okay. Well, I did a two sample. Let's see what it comes up with.
And I just did a one sample.
Okay, this is kind of weird.
The
Well,
output that it gave you.
what?
Were you saying that the output was weird?
Yeah, I'm trying to see if I did something wrong.
What did you get?
Let's see. Come on. Hmm. Okay. There means again. Let me try it as a one sample. Okay, so would we use our difference mean as the test value?
Um,
Or what did you use as the test value?
I used the test value. Hold on. Is the test value? Are you talking about in SPSS?
Yes, like if we're doing our t-tests. Is that the point? For some reason
I
I'm lost
mean,
there.
yeah, the test value I just did 0.
Test value is 0.
Right, because our null hypothesis is 0.
Okay. Well, then our t, if I do this one, if I do it with just the, come on. T value of negative 1.220.
Yep, that's what I got.
Okay, and the two-tailed of 0.257.
Mm-hmm.
Okay. Okay, what type of hypothesis test is appropriate? Okay, we talked about that. Are the requirements met for this test?
The requirements would be that it's normally distributed, right?
Right.
Okay. And I did a QQ plot for it, and it does look like it's fairly normally distributed.
Okay.
So it still tells us to just do whatever, though.
Okay. So we talked about the t number and our p-value.
Mm-hmm.
Degrees of freedom, you had 8.
Yep.
Okay. Okay. So we would fail to reject, right?
Because our p-value is greater than our alpha.
Yes. That's what I would say.
Okay. I always get it mixed up if we want to reject or fail to reject. I'm hoping that I get it down by the end of the semester.
So do I. Rather than testing a hypothesis, now say you just want to estimate the mean difference between wait times at the 95% level, what would you do? Just
We
go
could just
through
calculate the confidence interval.
Right. Okay.
And so we actually already did
Short.
that. Yes, I
What?
think. Sorry.
Yeah, 'cause to get up here, our confidence. So our lower bound for our confidence interval would be negative 3.0508, and our high side would be 0.9397, right? That's what it looks like when we did our thing.
Yep.
Okay. So what action do you feel should be taken based on this above?
The new way.
The new way doesn't help, right?
Well, no, I think the new way does help. Well, because we know that
because we failed to.
Sorry, go ahead.
Sorry. No, go ahead. Go ahead.
Well, we failed to. Oh, I see what you're saying. Since we failed to reject the null hypothesis, we accept the null hypothesis, which means that there's not that much of a difference.
Right.
Okay.
So we either stick with the old way or find a different new way. That's what I would say.
I see.
Is that what you would say?
Yeah, I agree. I'd say go and find a different new way. or just hire super amazing workers that exceed all expectations.
Okay. Are we ready for our quiz?
I think so.
Okay.
Let me just see if I can.
Zach. Where's that notebook I was using? Where's that notebook I was using? It was over here. It was up here. That's it.
So it's 16 questions.
Mhm.
Okay. Do you have it pulled up?
Yeah.
Okay, so the third one, we have a set of paired data that null hypothesis is the mean is equal to 0, and the alternative is that it's not equal to 0. And then so we get our sample size of 9 and the
Right.
difference mean 2.2, standard deviation 3.3. What's the value of the test statistic? Let me grab my cheat sheet. I feel like a horrible student. I don't know how to do this.
This one I don't. It's trying to remember.
Isn't this from last week's?
Hmm. It might be.
Oh. So we use the t-score formula.
Oh, we're trying to find the T, right?
Right. My confusion is that for that we need a population mean, but we're assuming that our population difference mean is 0, so we just use 0.
Oh,
So it's 2.2 minus 0.
mm,
I got 2 for my answer.
you got what?
2.
It's not your name.
Okay. Actually, I forgot the formula for T. Do you? And I can't seem to find it real quick. What is it? Just the formula? It would be the.
It's the sample mean
Mm-hmm.
minus the population mean, and then all of that over the standard deviation divided by the square root of our sample size.
No, I remember that now.
Okay.
Okay.
I won't get the anything. Stop being I'm not sitting on it. Just. There you go.
I got 2 as well.
There you go.
Now this next one confuses me. Do we use the probability applet for this?
Hey.
I would guess.
Okay, that's what I thought too.
And then we would just kind of work backwards.
How so?
Let's see.
Stop. I can still see you.
Oh, sorry, never mind. I read the question wrong.
Stop.
The probability of being greater than 2 is.
Okay, so
So,
I understand what you're saying now.
okay. Because I don't.
So I think what we do is we take that if we're using the normal probability applet, we take the probability that they give us,
Okay. Okay.
set our z-score to 2. Or no, that doesn't sound right.
Well, that gives us a Z score, but not the P score. We use
Right.
the applet as a P value. Let me see.
Have an idea. There was the t-distribution curve from the last lesson. That might help. No, doesn't.
Mhm. Hmm. Yeah, because the p-score would just be the 0.0403, so that doesn't make any sense. Did I miss something in the reading?
That's what I was just checking. What if, with the probability applet, if we select the rightmost area underneath the z-curve, and we do the area to be the probability that they give us, then would that z-score that shows up, would that be the p-value?
I don't know. Huh? P-value. See where I got this information from. Are we overthinking this? I don't know.
Maybe.
Wait. I have a question.
Okay.
Or a thought. Basically, the p-value is both sides, right? And remember last week where we divided it by 2 to get the one-tailed,
Yeah.
right?
Yeah, I remember
So if
that.
the probability of one tail is 0.0403, would the probability of basically HA be twice that?
I think so.
Or am I?
No, I think you're exactly right.
So then 0.081.
Yep. You're a
That's-
genius.
We'll try that. I we'll wait to see if it gets graded right, see if I'm a genius. Okay. Mm-mm.
Okay, so now we get to use SPSS.
Yep.
I'm okay with that.
Okay. No, that's not what I wanted you to do. Okay.
Okay. Is that frustrating having to go between the two different screens for SPSS?
Sometimes, but okay. Clues. And I don't know if it's because I have to take like remote control of a college computer, but it gets really slow when I switch over to that screen.
I believe you.
There we go. Oh. Okay. Form. Transform. Variable. Okay.
I'm curious to see what you got because I think that mine's wrong.
Can you stop that? I think I'm too new. What I'm doing.
Okay. So our mean is negative 31.025
That's what I got.
with a standard deviation of 341.157.
Yeah, that's where I was a little bit worried I was wrong, but that's exactly what I got.
Well, if we're wrong together.
Yeah, well, I mean, I guess we do have a really big numbers on, or a really big range on our first group. So I guess it makes sense.
Hi, Daddy.
Okay, so
And then our test statistic was our t-score, which was
yeah, which I'm
negative 0.407.
okay. I'm computing it now.
Okay. I found a shortcut.
Okay. Negative 0.407.
Mm-hmm. In this case, I don't know if it'll work for all of them,
Mm-hmm.
but once you get your two groups, you can just do a compare means of a paired t-test,
Uh-huh.
and that gives you all of the stuff that they're asking for.
Okay, and then for 8, did you get 0.689?
Mm-hmm.
And then fell to reject, right?
Because our p-value is less than our alpha.
Mm,
Our alpha is 0.1 this time.
we fell to reject if p-value is greater than alpha.
So then we would reject.
No, because alpha is alpha is 0.1, but we're at 0.689, right?
Right, so our p-value
So
is
we
less.
fell to reject.
Oh,
Huh?
okay.
Or,
I gotcha.
okay, so alpha is 0.1, p-value is
you're right. I'm sorry. I
0.689,
was
that's
reading
greater,
them.
right? Okay.
I need to.
And then I'd say on 10, we still fell to reject because even dividing, you'd still be at 0.3, right?
Right, because no matter what, we'd still be less. Yeah.
Okay.
I need to take that if p-value is less than, and if p-value is greater than, and paste that on the side of the wall or something.
Okay. And then let's download these ones. Well, that's easy. 11's easy. What?
Oh yeah, it is.
Because degrees of freedom are in -1, right?
Yep.
Come on.
Okay, so for the p-value, I got .001.
For p-value?
Yeah.
Okay.
No, I'll let you get it though, because I'm pretty sure I want to make sure that this is
Apparently it did. Too. This is good.
Okay. And since we're doing a does not equal, you'd use both sides, right?
right.
I got .001. Is that what you got?
Yeah, that is.
I guess we'll go with it.
And then in this case, because our p-value is less than our alpha, we reject the null.
Right.
Yes.
Okay, and so the p-value would decrease because we divide it by 2 if we're doing the greater than.
Yep, I agree.
Okay.
In which case we would still reject.
Right.
And 16 is so tricky.
We can always go with the good old not enough information.
That's what I think it is, because our p-values, wouldn't it be the same if it was greater than or less than 0?
That's what I would think, because your p-value is going to be highest when it's the not 0, but either way you divide it in half. I'll go with not enough information.
Maybe this is a trick question. And there's more than one right answer.
We'll see.
No, I agree. Not enough information.
Okay, shall we submit it?
Sounds good.
Right.
Okay. 100%. Woo!
Yay! Hey, I will see you Wednesday, sir.
Sounds good. Hopefully our sound is better matched up.
Hopefully. Infinite loop thing going this time.